So today we're going to talk about another way to measure angles. And most people are familiar with 360 degrees, which just arbitrarily cuts up a circle into 360 parts. But there's a connection between the length of the arc and the size of the angle. That's more useful to us in engineering and applications. So those are called radians. And we define 1 radian as the measure of the angle when the arc equals the radius. Okay? And radians don't have units, like there's no degrees or anything like that. The number just is there by itself. So we know that the circumference is 2 pi r. And if r equals 1, then the circumference would be 2 pi. And so there would be 2 pi radii, that's the plural for radius, radii in a circle. Okay, so if we go around the circle, if this equals 1, we would be able to put that on there 6.28 ... times. Okay? So if we're converting degrees to radians, we multiply by pi over 180. And if you think about it, so what we're used to is 360 all the way around, so 360 would be 2 pi. But if we divide that by 2, then pi equals 180. So that's kind of what I like to keep in my mind when I'm doing these conversions, is that pi is equal to 180. Pi is equal to 180. But you certainly can just memorize these two. So degrees to radians, we multiply by pi over 180. And to switch from radians to degrees, we multiply by 180 over pi. So here we have 200 degrees. So we're going to multiply that by pi over 180 degrees, technically. So the degrees kind of cancel out. And we can reduce that, divide by 10. And then we have divide by 2. So that would be 10 pi over 9. Okay. And we're just going to do the same thing on both of these. So we're going to multiply by pi over 180. We're going to multiply by pi over 180. So here that's out. And so that one is just 7 pi over 18. All right. And here, that maybe you can see that that's going to be 5. If not, you can divide them both by 6 and reduce it. But so another way to write that would be we could say 1/5 pi, but normally we're going to write that as pi over 5. Okay. Now here, we can multiply by 180 over pi, but remember we said that pi is 180. So really you could think about it as just 180 over 12. But I'm going to go ahead and show the conversion on here. This one's going to be 180 over pi. So these pi's will cancel, but we would get that same thing if we just think like pi is 180. Pi is 180. So that's how I think about it. Okay, so here maybe you just want to take 180 divided by 12, so that's 1 and 5, so that's going to be 15 degrees. So pi over 12 is 15 degrees. Okay, next one, 180 over pi, pi's cancel, so it's just like pi is 180. So 18 goes into there 10 times, so 11 times 10 is 110. And this one, maybe you notice that this is 2.5 pi, so that's more than 360. So I already should keep that in mind. 180 over pi, pi's cancel. 180 over 2 is 90. 90 times 5 is 450. All right. So I'm going to move this up here. Okay. So a couple things as what we do we're going to use what's called the unit circle. And the unit circle is when r equals 1. So, unit circle. So that's kind of the first half of the lesson was degrees and radians. Now we're kind of talking about something else. The title of the lesson was radians and the unit circle. So we're not going to look at the whole unit circle. We're just going to look at the first quadrant here, mostly. But the unit circle is when r equals 1. And that is going to allow us to look at a few things here. So first of all, you've got to remember SOHCAHTOA. So sine is opposite over hypotenuse, etc. So the coordinates are alphabetical. We've done a lot of things in alphabetical order this year, but x and y, right? So that should make it easy to remember that x is cosine and y is sine, because that's in alphabetical order. X is first and y is second in the alphabet, or well, I should say x comes before y and c comes before s. So that should help you remember which is which. Okay, now we said the radius is 1. We should be able to see that here as well. The radius is 1, 1, 1. So that's good. We could put that in 3 different places. Okay, so if we look at this, this distance over here would be x, whatever these points are. This would be x, and this would be y. So if we look at that, so if we looked at this triangle right here, and we looked at this angle, and we thought about cosine, cosine is adjacent over hypotenuse. So the cosine of theta would equal x over 1, and so that shows us, if we multiply both sides by 1 or divide by 1 here, either way, that x is equal to the cosine of theta. So that's just showing us that this is true here. And if we look at y, that's opposite over hypotenuse, so that's sine. So the sine of theta is y over 1, so y is the sine of theta. So really here we're just showing where this comes from, that that's true. Okay? So now we want to explore that a little bit more. So okay. So if we look at a 45-45 right isosceles triangle, if the hypotenuse is 1 and we want to try to go to the leg, we would divide by root 2. Okay, so that would be 1 over root 2. And if we rationalize that, that would be root 2 over 2. And it's isosceles, so this would also be root 2 over root 2. Okay? And if we look at the 30, 60, 90 triangle here, to go from the hypotenuse to the short leg, we divide by 2. And then to go from the short leg to the long leg, we multiply by root 3. So we've gone over that quite a few times. So we go there and then here. Always go to the short leg first. Okay, so as we come around here, we want to look at these points. So starting off here, that's going to be 1, 0. So that should be pretty obvious to everybody. And that's for 0 degrees and 0 radians. And if we come up here, this is 0, 1. And that's for 90 degrees. And if we want to switch that to radians, remember that I said that pi equals 180. So 90 is half of 180, so that would be half of pi, or pi over 2. So those two should be pretty easy. If you're looking here and you see a 0 degree angle, then you know the cosine is 1 and the sine is 0, or straight up here. Now, I think that this one should also be pretty straightforward because that's 45 degrees. So that is going to be root 2 over 2 and root 2 over 2. And that was 45 degrees, which again is half of this, so that would be pi over 4. Or you can just use a conversion, multiply by pi over 180. Okay, so really that just kind of leaves two things. So what I want you to think about is basically there are 5 numbers. In the first quadrant there are 5 numbers. And those numbers are 0, 1/2, root 2 over 2, root 3 over 2, and 1. Okay? And there's a pattern to that, and we can talk about that pattern as well. But so the 2 numbers I'm focused on are these 2, and I say this is the short one, and this is the long one here. So when I look at this over here, let's take this point right here. And they'll go over this again in Algebra 2 and in Pre-Calculus, College Prep Math, all those classes, they'll do it again. But as we look at this angle right here, and when you get good at this, this kind of happens in your head. So this is a 30-degree angle. And so when I look over here, so that's going to be 30 degrees, and that's going to be, if we multiply that by pi over 180, 30 over 180 is 1/6. So that's going to be pi over 6. So when you look at this, you can see that it has a long x. The long x. So it's the long number. So it's root 3 over 2. It's the bigger number. Root 3 over 2. Okay? So the way I think about that is I go, okay, 30 degrees, and then I look at this, and that's going to be a long x and a short y. So the long x is root 3 over 2, and the short y is 1/2. Okay? And if we come up here, that's going to be a short x. So that's 1/2, and that's going to be a long y up to here. So that's root 3 over 2. And that was 60 degrees, and that is pi over 3. 180 divided by 3 is 60. Okay, so that might not mean a whole lot to you right now, but it'll get better. Now another thing to consider is tangent, and we have something called the quotient identity. Tangent is sine divided by cosine, so that's how we're going to fill out the tangent spots down there. Okay, so let's fill this out, and so 0 degrees is 0 radians. Okay, and if we go all the way around the circle and come back to there, 360 degrees, that's 2 pi. Okay, and then 90 degrees, we talked about that, that's pi over 2, and 180 is pi, and 270 would be 3 90s, so that's 3 pi over 2. Alright? So we have that. Now if sine is y, and if we go over to 0, then we're not going up or down at all, so that's going to be 0. And cosine is 1. And we can think about what we just said right here. Tangent is sine over cosine, so we could take sine divided by cosine, and we would get 0. Alright? I'm going to do all these, they're called the quadrantal angles. Quads, because they're 90 degrees apart, 4 of them. Okay, so sine of 90 degrees. 90 degrees is straight up. Sine is y, so that would be 1. Cosine is x. If we're going straight up, we're not going left or all. That's 0. And if we take sine divided by cosine to get tangent, that's going to be undefined. Okay. And 180 is directly to the left, and so sine is the y coordinate, so if we go straight to the left, we're not going up or down at all, so that's 0 again. And cosine would be the x coordinate, and if we're going over there, that would be -1. And if we divide those, 0 divided by -1 is 0. And then the last one of these, 90 degrees, is straight down 270. So the y is -1 if we go straight down. And if we go straight down, we're not going left or right at all, so that's 0. And again, if we divide those, that's undefined. Okay? So on this chart, I'm going to jump back to the 45 because that should be pretty straightforward also. So that was pi over 4. And these were both root 2 over 2. And tangent is sine divided by cosine, so that would be 1. Okay? And let's finish off this chart here a couple. So 30 degrees is pi over 6. It's 180 divided by 6, and pi is 180. Okay? So sine is y, and if we have 30 degrees, that was this one here, 30 degrees, then y is short, so that's going to be 1/2 for the short y there. And cosine is long, cosine is x, that's root 3 over 2. Now, to get tangent, we can take that divided by that. Now, actually for tangent, I just memorize these, actually. But I'll go ahead and calculate it to show you where it comes from. So I would just memorize this. But we can calculate it. So if we take 1/2 and then we put that over root 3 over 2. So that's a complex fraction. You could multiply by the reciprocal, but I'm just going to multiply by 2 because it's a complex fraction, so multiply by the common denominator. So that gives us 1 over root 3. And if we rationalize that, we're going to get root 3 over 3. Okay? So 60 degrees. So in my mind, I would think, okay, 60 degrees is up here. That's a short x and a long y. Well, let's do the radians first. 180 divided by 3 would be 60. Okay, so a long y, that's going to be root 3 over 2. And a short x, that's going to be 1/2. And if we divide these by each other and multiply by 2, we get root 3 over 1. So that's going to be root 3. So the way I memorize that is I just remember that, so there's a lot of 3's for tangent. Tangent has a lot of 3's, and 30 is less than 60, and root 3 over 3 is less than root 3. So that's how I remember that. All right, so let's wrap this up. Okay, so down here, pi over 4, that's 45 degrees, that's straight in the middle, that's where they're equal, so that's going to be root 2 over 2. So I don't even have to do much with that at all. Now, here's what happens with this. So sine, so this is supposed to be a thought bubble. So here's what's supposed to happen. You think about 30 degrees, and 30 degrees is kind of like this, and it's kind of a smaller angle, and sine is y. Okay, so I think y short. Y is the short number. So this is all, and you can write it down at first, but eventually the purpose of this, that's supposed to be a thought bubble, like in a cartoon where they show the thought bubble, what they're thinking. So you're thinking 30 degrees and small angle here, and then sine is y, and y is short, and so the short number is 1/2, and when you get good at it, that's going to happen very fast. Okay. Now, tangent of 60. Now that just, okay, so to me, I know that 45 is 1, and then I know there's 30 and 60, and 30 is less than 60, so 30 is root 3 over 3, and 60 is root 3. Okay, so that just comes over time and memorization and studying. And those things. Okay? And now 90 degrees, that's straight up. And cosine is x, so that's going to be 0. All right? And you're going to do this for the next couple years, so it should get better. So don't worry too much. Okay, last question, multiple choice. What is the length of arc AED? Arc AED. So we can see that these answers are all in radians and the picture's in degrees, so all we need to do is kind of do that conversion. But we need to know what this one is, so we can see they gave us these three, so we're going to add these together, and we could do that pretty easily. This is 75, that's 195. So that's 195. And I think what I'll just do is switch and find this, so that's going to be 360 minus 195. So that is going to be 5, and then this will be 6, and then 1. So this side is 165. So we have 165 times pi over 180. So we can see, hopefully we can see pretty clearly that's not the answer. So 5 goes into this 33 times, and 5 goes into this 36 times, and then both those can be divided by 3. So that's that. Finally, we have a cartoon down here, and the thing about the cartoon is the thing about your education, the thing about broadening your mind and studying, and sometimes maybe you wonder, you see your friends out playing and you're studying because you're in honors math class and maybe other honors classes, is there's a reason that you're getting an education. There's a reason that you're working hard, and that is, for opportunities in the future. But and this is just a simple example, but here's this cartoon, and so it says you have 10 minutes left, people, and then he's like, you can do this, Peter. He's talking to himself, and he's looking at this. Now, based on this lesson that we just did, I hope that all of you can look at this. If you were reading the newspaper or you're online and you saw this cartoon and you go, oh, those are radians, or maybe you wouldn't even remember those are radians. Oh, that's another way to measure angles, or 20 years from now you might not remember they're called radians, but you'd be like, oh yeah, I remember we studied that in geometry or something. So then all of a sudden it looks like a pizza, and then the teacher says, let's try not to drool on our test, Mr. Fox. That's the character's last name, Peter Fox. So, and then he says, trig class should not be the period before lunch. And so you can see he's hungry, and he's looking at the circle, unit circle, and he's thinking about a pizza. And it's really not that, I don't think it's that funny, but I know what it's about. I understand it, and I can decide if it's funny or not. Most people will look at that, they don't know what that means, and so, I mean, maybe they could put it together, math class circle. But anyway, so your education is important. It lets you think about a lot of things and see a lot of things. So keep working hard. We're almost done. Have a good day.